In an 8085 microprocessor, which one of the following instructions changes the content of the accumulator? Now, accumulator is a very basic, register from where the data is first fetched. Okay. Now there is SBIBE, that is H. Okay. Now the answer is this. First, you need to understand that whenever some arithmetical or logical operation is done, there is some flag changing. That is, sometimes, there will be a carry, so carry flag will be set. Sometimes whole data is 0, so 0 flag will be set. This is how. So this question answer lies in that the arithmetic or logic operation update the data of accumulator and the flag register, which you see here also. Only option 4, which is SBIBH, this is only the arithmetic operation. What this operation does, or what this instruction does, this instruction adds the content of the accumulator with the data which is given already here, BE, and stores the result again in the accumulator. So that is how the content of the accumulator is going to change, because this is arithmetic and logic operation, and this specifically deals with the change of the accumulator content. The ALU of a microprocessor performs operation of 8-bit 2's complement operands. What happens when the operation 7A and minus A2 is performed? This H is standing here for the hexadecimal. So basically the data is 7A and A2. Now the answer here is, if you're doing by yourself, you can just check that this is D8 in hexadecimal. The negative flag is set, right? How does it work? I'll just explain one by one. See, first of all, the number given here, this is 7A minus A2. So you're subtracting 7A, because it is hexadecimal, we can change it into binary. B is A2, you can again change it into the binary. I hope you'll be able to do it. Okay. So this hexadecimal to binary conversion is being done. Now this is a subtraction event or operation, A minus B. But there is nothing called A negative. Subtraction is nothing in microprocessor. So you have to add the negative of B. How to find the negative of B? You take the 2's complement of B. That is, take the 1 complement, that is make the 1 to 0 and just add 1. So wherever B is there, A2, we have to find the 2's complement. Now 2's complement is there. Now you can add this with the 7A. So the 2's complement, if A2 has to be added to 7A. Now you see the first one. This 1 is coming. As this is the most significant bit, and this is 1. The result is negative. Hence the negative flag will be set. And there is no carry involved in the result. The carry bit is 0. That is, there is no overflow. That is why the carry flag will be 0. Okay. So this is how it will be done. For the 8085 assembly language program given here, the content of the accumulator after the execution of the program is. Now before I go ahead to actually explain it, the answer is 67H. If you're able to do it, it's praiseworthy. But you need to understand each and every instruction first. I'll tell you about the solution in just a bit. See, first of all, MOV will do what? Move will, see, move B comma I. What it will do? B is your destination register. A is your source register. So this move, this instruction transfers the source register content to the destination register. Okay. From A, it will go to B. Okay. From source, it will go to the destination. Is that clear? Coming to MVI. MVI, this we have the one will be the register, another will be the data. So this instruction transfer the data into the destination register. MVI. If it is memory, this instruction transfers the data into the memory. XRA. XRA can be with memory, it can be with the some register. Okay. So this XRA is nothing but XOR, and A stands for accumulator. So the contents of the accumulator are XORed with the contents of the register or memory. So the XOR is simply, if it is 1 and 0 or 0 and 1, it will give you 1. If it is 0, 0, 1, 1, it will give you 0. Right? So XRA stands for that. Now, coming to one more here, which is your RAR. RAR. Now, RAR is nothing but using the carry flag, you are rotating, or you can say shifting one bit. So each binary bit of the accumulator is rotated right by one position through carry flag. That is, it is shifted one piece on the right through the carry flag. STC, the carry flag is set with this instruction. So STC, it will just set the carry flag to 1. And CMC, the carry flag is complemented with this instruction. Whatever is the carry flag, if it is 1, it will become 0. If it is 0, it will become 1. Now let us come to one by one. MVI A45H. What did I tell you? MVI. See, this is accumulator is now getting 45H. So 45, this is the binary equivalent. What is MOVBA doing? Now, the register B is loaded with accumulator value. Accumulator was having what? 45. Now the register B is loaded with the accumulator value. Now B has the accumulator value. So A and B are having the same value. So it is same. This the binary equivalent of 45. Now STC will do what? Carry will be 1. CMC will do complemented. So carry was 1. It will become 0. And then RAR will do what? See, rotate the value of accumulator through carry. So you just have to see the A or B and just see we have just shifted it on 1. That is, if you remove the 1 from right hand side and add a 0 on the back, it will be same. So through the carry, through the 0, we have to use 0. Okay, we are shifting it. So remove 1 and add a 0 here. This is what shifting means. Now XOR is what? Now accumulator is XORed with this. So you have to XOR A and B and put it in the A. So let us XOR. Just remember in XOR, if it is 0 and 1, what will come? It will 1 and 0, 1 will come. If both are zeros and both are 1, then 0 will come. Right? So when you XOR it, I hope you are getting it. 0, 0, 0, 1, 1, 0, 1, 1, and 1, 0 and 0, 1, it will be 1. Then the 67H will come if you converted this into hexadecimal. The clock frequency of an 8085 microprocessor is 5 MHz. If the time required to execute an instruction is 1.4 microsecond, then the total number of T states needed for executing the instruction is? The answer is 7. If you are able to do it, it's very good. But let me tell you, what is the concept here? The time required to execute an instruction is given by number of T states or T cycles multiplied by the time period of the clock, T clock. So the clock frequency is already given. Clock is 5 MHz. Frequency is 1 by time. So in order to find the time, you just take the inverse of 1 by 5. It is 1 by 5 you have to take. 1 by 5 MHz, it comes to 0.2 microsecond. Right? So time and frequency are inversely related. Now time of clock we have got. Number of T states we don't know. But we do know that time, what is the actual time required for the instruction? Which is 1.4 microsecond. And we have to find T clock we have already found 0.2. 1.4 microsecond is the total time of execution and is equal to 1.4 by 0.2. 1.4 by 0.2 is 7. This is the answer.